So, hello everyone. Hello everyone. So, in this video, we are going to cover Unit 4 and 5 topics. Okay. So, there are some topics which I am going to discuss today. Uh, Topics are introduction to shift registers, ring counter, synchronous and asynchronous counters, and designing of combinational circuits like code, converters, and counter etc. And fifth unit topics are semiconductor memories, designing with read-only memory, and decoders and encoders, multiplexer and demultiplexer. So date is 4th of April 2026. So let's begin with unit 4. Topic is shift registers and ring counters. Shift register and ring counter. Think of shift register as a digital conveyor belt. Okay, think of shift register as a digital conveyor belt. Now, what is conveyor belt? It used to rotate a wheel through a belt. Okay, so shift register. I hope this all is visible. Yeah. So first is shift register. So basically, it's a group of flip-flops. Group of flip-flop. Okay, it's a group of flip-flop connected in a line. Connected in a line. When clock pulse hits the bit in the first flip-flop moves to second. When clock pulse hit the bit in the first flip-flop moves to the second to third, and so on. It a flip-flop connected in a line. Okay, when a clock pulse hits the bit in the first flip-flop moves to second. First flip-flop moves to second, then second to third. It moves to second, then second to third, and so on. It used to turn serial data into parallel data. Serial data into parallel data. Serial data into parallel data, or vice versa. Ring counter. So this is shift register. Where the output of the last flip-flop is connected back to input of the first. Where the output of last output of last flip flop is connected last flip flop is connected back to input of first, connected back to input of first. The one just keeps rotating in the circle. Okay, the one just keeps rotating. One just keep rotating in the circuit. Synchronous versus asynchronous. Second topic is synchronous versus asynchronous. So synchronous NOUS, okay. So basically counters are circuits that count clock pulse in a binary. Basically count clock pulse in binary, okay. Binary means 0 or 1. Yeah. So first synchronous, like a military march, every flip flop in the counter is connected to the same clock signal. Okay, connected like a military march. Every flip flop in the counter is connected to the same clock signal. Connected to the same clock signal. They all change state at the exact same moment. It is faster and more reliable than ripple counter. Faster and more reliable faster and more reliable than ripple counter. Okay, same moment. Now asynchronous ripple counter, like a row of falling dominoes. The first flip flop is clocked externally. First flip flop is clocked externally. But its output serves as the clock. As the clock of next one. Okay, so at the clock of next one, because each stage has a tiny delay, it is asynchronous, not happening at the exact time. Basically asynchronous means not happening at the exact time. Okay, yeah. So move on to the next topic. Designing combinational circuits. Designing combinational circuit. Designing combinational circuits. Combinational logic does not have memory. Combinational logic. Combinational logic does not have memory. Combinational logic does not have memory. The output depends only on the current input. The output depends only on the current input. Output depends on current input. Okay, so here is designing combinational circuits mean code converters. Code converters. Code converters. These translate binary from one format to another. These translate binary from one format to another. From one format to another. One format to another. For example, a binary to gray code converter, or BCD 7-segment converters. Translate binary from one format to another. Okay, which takes a 4-bit number to decide which LEDs on the calculator display should light up. A binary to gray code converter. A binary to gray code converter. Designing process. Draw the truth table. First is draw the truth table. Second is simplify using Kmap. Third is draw the final logic gate. Okay, final logic circuit. Now semiconductor memories. Fourth topic is semiconductor memories. So basically semiconductor memories, these are chips used to store digital information. These are chips used to store digital information. Okay, digital information. These are chips to store digital information like zeros and ones. So इसमें आता है RAM, random access memory. So volatile memory है, it is volatile. It's fast but forget. Everything when power goes out. Forget everything when power goes out. Now ROM means read only memory. It's read-only memory. Non-volatile memory. It is non-volatile memory. Non-volatile memory. It keeps data even without power. It keeps its data even without power. It keeps its data even without power. Okay, without power or electricity. Using for storing the startup instruction of a computer. Useful for storing startup. Useful for storing startup instruction of computer. Okay. So now designing with ROM and PLA. Fifth, designing with ROM and PLA. ROM and PLA. Instead of using hundred of individual gates, we use programmable logic. Instead of using hundred of individual gates, instead of using hundred of programmable codes, 100 programmable codes, 100 individual gates, 100 individual gates, 100 of individual gates, we use programmable logic. We use programmable logic. Okay, we use programmable logic to simplify design. Now ROM logic means read only memory logic. So ROM logic so you can treat a ROM like a giant truth table. You can treat a ROM as a giant, means very large truth table. Okay, very large truth table. Very large truth table. You provide the input and it gives you a pre-stored output. You provide the input. You provide the input and it gives you. You provide the input and it's give you pre-stored output and it's give you pre-stored output. Okay, PLA means programmable logic array. Now PLA means programmable logic array. Programmable logic array. So basically programmable logic array, a more flexible chip that has a grid of AND gates. More flexible that has grid. You understand what do I mean by grid? Grid means lines of AND gates, of AND gates and OR gates, of AND OR gates and OR gates. You program it by blowing fuses to create the exact logic paths you need. You program it blowing, by blowing, fusing, by blowing fusing, by blowing fuses to create the exact logic path you need. Okay. Now encoders and decoders. Sixth is encoders, encoder and decoder. Encoder and decoder. So these are the translators of the digital words. You can say these are the translators of digital world. Translators of digital world. First, decoder takes a coded input. It takes a coded input. It takes a coded input like 2 bits and activates the specific output like 2 bits and activate specific output 4-bit. It unpacks information. It just unpacks information. Okay. Decoder and encoder. Encoder, the opposite, just the opposite of encoder. The opposite means it takes many input and compress them into smaller binary. It takes many input. It takes many input and compresses them into smaller binary. And compresses them into smaller binary, smaller binary. Code, for example, binary code. For example, keyboard encoder takes a key press and turns into the binary number. Keyboard takes a key press and turns into the binary number of CPU understand. Okay. Now let's move on to the multiplexer and demultiplexer. Multiplexer MUX. So think of these as a digital traffic switches. Multiplexer and demultiplexer is a digital traffic switches. So basically it indicates that which signal will pass which time. Okay. So multiplexer is many to one. Okay. Many to one. It has multiple data input but only one output. Multiple data input but only one output. Okay, but only one output. A select line act like a remote control to choose which input gets to go through the output. Okay, demultiplexer. Demultiplexer. So one to many. It is one to many. Means one input and it takes one input and many outputs outputs and many outputs. Dash to one to many possible outputs based on the select line. Based on the select line. Okay, based on the select line. So these were some topics of unit 5 and 4. So thanks for watching.